Welcome back to ECE 207 Solutions. We're looking at a previous exam number 3 problem, and it's problem number 2. We are actually wanting to determine, there's a couple of different op-amp circuits on this particular problem, and we want to look at each one and determine if either of those, or what condition those are operating in, whether they're using negative feedback or positive feedback. And what we will see is that when we have this feedback connection through the inverting input of our op-amp, that's typically going to then allow us to conclude that we do have negative feedback. And that's a good thing. That actually allows us to use our summing point constraint in the analysis. And if we then use the summing point constraint, and after we've analyzed our system, if we find that the output voltage is now actually exceeding what the supply voltages are, let's say this is minus V sub Cc and this is plus V sub Cc, then we've gone outside the linear operating range and we've reached saturation. And even with negative feedback, we can have saturation, and we will go towards the rails, either positive rail or negative rail, for V0, and not actually achieve the V0 that we would like to think we were getting based on the externally connected parameters around our op-amp, which in this case we have 4 resistors, R1 through R4, that are around this particular op-amp. This op-amp is really configured in an inverting amplifier configuration, and the reason why that this is configured this way versus, let's say, maybe the more typical inverting operational amplifier configuration, where we have the feedback resistor R sub F, and here's our input resistor R sub I, and maybe this is our input voltage V sub I to ground, and here's V0. The difference between this configuration on the right and this configuration on the left is that the one on the left actually allows us to use smaller resistor values here than what we might be calling for there with R sub F in order to achieve the same amplification quantity or gain in our circuit. Let's get back to the problem at hand, which is to examine this particular circuit that we've drawn on the left, and well, that's drawn for us in the exam, and see if that particular circuit is operating or functioning in a negative feedback configuration. What we'll do is we'll look at, and there are a lot of different ways to analyze this, but you need to get comfortable with these KVL relationships around air gaps. But we may actually look at this voltage difference between the non-inverting terminal, which is indicated with the plus sign, and the inverting terminal indicated by the minus sign. If we think of this particular voltage as being, let's say, V sub P up to the positive terminal, and this voltage, we could have that reference to ground even to this point, that might be called V sub N for the inverting terminal. Now we can actually see that if we did a KVL in this particular fashion, we would see that we have minus V sub N minus V sub D plus V sub P is equal to 0, or V sub D, if we take it on the right hand side, we see that it's now, or negate both sides or multiply by -1 and then put the v sub p and v sub n on the other side, we see that this difference voltage between the non-inverting and inverting terminal of our op-amp is just the difference between the voltage levels at the non-inverting terminal plus and the inverting terminal minus. Let's now just assume, for argument's sake, that we've applied we are applying a voltage VI, which will result in a voltage V sub n at the inverting terminal of our op-amp. V sub p, I hope you can see, is actually equal to 0 in this case because it's tied directly to ground. Let's assume, just again, we're trying to find whether this circuit is connected in a negative feedback or positive feedback configuration. Let's make the assumption that V sub n is positive. If that's positive, then what's actually going to happen? Well, we know that V naught is going to be proportional to this V sub d. And actually V naught is going to operate in such a way to force V sub d to be very small, or effectively 0, if we are operating in the linear operating region and not saturating, and if we are in a negative feedback configuration. This is the relationship then that we are going to use to try to argue whether or not it's positive or negative feedback in place. If V naught is proportional to a positive large gain A sub OL, let's say that's the open loop gain of our op-amp, which is huge, and V sub D, then in this particular problem, V sub D, if we look at what we have, it's now going to be equal to V sub P minus V sub N. If we look at V naught, it's now proportional to A sub OL times V sub P minus V sub N. And what did we assume? We assumed that V sub n in this original statement was positive. If V sub n is positive, then it's actually going to cause V naught to move in a negative direction, or negative, because V sub p, remember, in this particular configuration was 0. We now have V naught is a negative number, and this V naught is actually being fed back by this combination of circuitry back to that particular point, because this interconnected structure of resistors will allow some of this output voltage V naught to be fed back to V sub n through this set of interconnected resistors. Meaning V naught was positive, V sub n was positive, V naught is negative, and so we're trying to force Vn in the opposite direction to what it is, and because of that we have negative feedback in part A. Let's look at part B. Part B, again, we should expect that we're going to be in negative feedback configuration because of that particular interconnection between the output terminal and this inverting terminal of our circuit. Let's now look at what's going on here. Let's assume, to argue, that we have this particular voltage, which is really just V sub P that we're familiar with. That's the voltage at the non-inverting terminal, V sub n is this voltage at the inverting terminal, and V sub D is that drop between there. Or if we do another KVL, we can see that we have minus V sub P plus V sub D plus V sub n is equal to 0. If we solve for V sub D, we end up with V sub P minus V sub n. Now, let's assume that, again, we could assume any different or any combination we want. We just need to see that the output is moving in a direction opposite to force V sub D equal to 0, and we're feeding that information back. For checking that out, let's assume that V sub P is positive. If V sub P is positive, then what we have is V sub P minus V sub n equaling V sub D, or we now know that V sub P is equal to V sub D plus V sub n. And what do we know about V naught? V naught is proportional to V sub D. So maybe what I should have done was kept this in terms of V sub D. So this is now A sub OL times V sub P minus V sub n. If V sub P is positive, then what we have is V naught is this large gain times this differential voltage V sub D. And what we are wanting to do is determine whether V naught is helping V sub D go to 0. And to look at that, what's happening is this output voltage is now getting fed back to V sub n. And if V naught is positive, then V sub n is going to be making it to be proportional to V naught, and so we're now increasing V sub n. Let's look at this another way. So V sub D, if we say V sub D is positive, let's assume that. Maybe that will make it easier for what we want to do. Assume V sub D is positive, which says that V sub P minus V sub n, which is V sub D, is greater than 0. Now if we look at our circuit, we see that V naught right there is being fed back through this combination of R3 and R4 to V sub n. And V naught is proportional to V sub D. So V naught is going to be a positive number, but that's getting fed back through and causing V sub n to increase. Which is actually going, because of this, it's being the inverting terminal, it now takes away from V sub P and causes V sub D to actually decrease. Because V sub D is now moving opposite or getting smaller by this feedback interconnection structure, or V sub D is being forced to move opposite of its original value, then negative feedback is present. And we can now go back and circle that negative feedback.